Let's talk about cement. It's the literal foundation of our modern world. That silent, gray glue holding pretty much everything together. It's so common, we barely even notice it. But behind that familiar look is a whole world of specialized science that decides how and, frankly, if our world stands at all. I mean, just look around any city. You'll see it in action everywhere. Construction is like the constant pulse of our civilization, shaping everything from those massive skyscrapers to the very foundation under your feet. And it all starts with choosing the right stuff. So here's the question that really kicks this whole thing off. Is all cement just cement? Is the binder used to hold back 1 billion gallons of water in a dam the same stuff they use to make a slick, polished floor? Well, the short answer is nope, not even close. And the reasons why are actually pretty fascinating. All right, let's dive into our first big challenge, time. Because in construction, time really is money. And sometimes you're in a serious race against the clock. Think about it. You're repairing a super busy highway, or maybe you're in a factory churning out concrete panels. You can't just stop traffic for weeks on end or let all your equipment sit idle. Every single hour you spend just waiting for standard concrete to get strong enough is an hour of lost time and money piling up. So this problem created a real engineering challenge, and the answer was rapid hardening cement. It's specially designed with more of a compound called tricalcium silicate, which basically acts like a turbocharger for strength. We're talking about getting the same strength in just 3 days that your regular, ordinary Portland cement might take a whole week to reach. This means you can get those forms off early, turn projects around way faster, and, you guessed it, save a ton of money. Okay, so we've solved for speed, but what about the challenge of just sheer size? Let's go from a race against time to the problem of building something truly enormous. Just try to imagine pouring the concrete for a massive dam or huge skyscraper foundation. We're talking about thousands and thousands of tons of this stuff. When all that concrete starts curing at once, it creates an incredible amount of heat inside. So this whole thing has a name, the heat of hydration. It's just a natural chemical reaction that happens when water and cement mix. It releases energy as heat. Now, in a small pour, that heat just escapes, no big deal. But in a massive structure, the heat gets trapped in the core. This can make the inside way hotter than the surface, which creates stress and can lead to some seriously catastrophic cracks. To get around this, engineers came up with low-heat cement. It's cleverly designed to slow that whole chemical reaction down, so the heat gets released much more gradually. This keeps the internal temperature of the concrete under control, prevents those dangerous temperature swings, and makes sure these giant projects are built to last. So we've handled speed and we've handled scale, but what about just survival? Because these structures don't exist in a perfect bubble. They have to fight against the elements every single day of their lives. I mean, take a structure built right by the sea, or one that has its foundations in certain kinds of soil. These places can be incredibly hostile. They're filled with chemicals that are constantly trying to eat away at the concrete. One of the biggest bad guys here is sulfates. You find them in some soils and in seawater, and they react with a key ingredient in ordinary cement. This reaction actually causes the concrete to expand, to crack, and to literally just fall apart over time. So the solution is sulfate-resisting cement, which is made with very low levels of that specific ingredient, basically neutralizing the threat before it can even start. But chemical attacks aren't the only problem. Probably the most common enemy of all is just plain old water. And to fight that, we need a material that is hydrophobic. It's a fancy word that literally just means water-fearing. And wow, the difference is just crystal clear when you see it like this. On the left, a drop of water on normal mortar just soaks right in, right? It's creating a pathway for moisture and decay. But on the right, with hydrophobic cement mortar, look at that. The water just beads up and rolls right off. It's made with special agents that repel water, protecting the structure from the inside out. So far, we've been all about strength, durability, and survival. But what about beauty? Because in modern architecture, cement is also a massive player when it comes to design and just looking good. This quote just captures the whole idea perfectly. Choosing white cement isn't just about picking a color you like. It's a fundamental design decision that has real functional benefits. And you have definitely seen it in some of the most jaw-droppingly beautiful buildings in the world. From the glowing white facade of the Sheikh Zayed Grand Mosque to the pristine petals of the Lotus Temple in India. It's also the secret behind high-end terrazzo floors, decorative panels, and even the clean grout lines between the tiles in your bathroom. Its power really comes from its purity. They make it using raw materials that have very little iron, and that gives you this bright, clean, white base. This not only looks amazing on its own for a minimalist vibe, but it also acts like a perfect canvas, making any colors you add to it more vibrant and true. Plus, all that brightness reflects more light, which can help keep buildings cooler and even cut down on lighting costs. Okay, so we've seen all the specialists, the rock stars of the cement world. But what about the cement that gets used in most everyday construction? Let's bring it back to the most common choice that builders have to make. The two real workhorses of the industry are ordinary Portland cement, or OPC, and Portland Pozzolana cement, PPC. And there's a really clear trade-off between them. OPC is like a sprinter. It gains strength faster right out of the gate, which is great for general construction. But PPC, which has stuff like fly ash mixed in, is more of a marathon runner. It has a lower heat of hydration, better chemical resistance, and actually gets stronger in the long run. Oh, and it's also more eco-friendly since it uses an industrial byproduct. Which, brings us right back to where we started. Underneath it all, holding our entire world together, is this unseen foundation of carefully chosen, highly specific materials. At the end of the day, what all this really shows is that cement is not just some commodity. It is a highly engineered material. Picking the right type for the right job, whether you need speed, scale, resilience, or just pure beauty, is one of the most critical decisions in all of construction. It's what makes sure our buildings aren't just built, but built to last. And that kind of leaves us with a final thought, doesn't it? From cements that can fight off harsh chemicals to new types that use recycled materials, we're already seeing some incredible innovation. It just makes you wonder, as we keep pushing the boundaries of what's possible, what will the next generation of these essential materials even be able to do?